We have covered the first three objectives of this chapter, and now let's look at the remaining four. I will simply be skimming through them because, after all, a lot of these will resurface later on during the course, and it is in those later chapters that we will actually look at them in some detail. Now, we have talked about the necessity of this thing called an audit trail, but we're talking about it in the context of manual paper-based systems. But of course, even when we computerize, when we take our manual system and we now computerize it, and we are now running computer-based systems, even then, it is still important that we are able to account for every little thing. And so, even in the context of computer-based systems, the idea of an audit trail is still paramount. Of course, in this context, it will be less observable, but we still have to be able to do it. Now, when working with computer-based systems, of course, things will be stored in magnetic files, and there are several types of files. For instance, your book talks about a master file that contains data, a transaction file that is a temporary record reel of your transaction records. It talks about a reference file that stores, for instance, things like text tables. So effectively, you could think of it as a lookup table of some sort. There's an archive file that contains records of past transactions. So these will be the different types of files that your system would be sitting on top of. And as I said, even in this context of a computer-based system, we still need to be able to follow things, perhaps from the end all the way back to the beginning. In this case, be able to go back all the way to the source document that triggered everything, and perhaps even be able to go back to the custom order, be able to call a customer and say, did you actually make this order, and were you looking for these items, or what happened here? So the book discusses this picture, and here are the steps in detail. Take the time to go through it and try to understand what is happening here. But the critical thing is that idea of traceability. We need to be able to trace things and ultimately be able to say the reason this happened is because of this particular cause. So that is really important. Okay, now when talking about computer-based systems, sometimes people talk about things that are called models, and one example of a model is this that is called a flat file model. In this case, essentially, your system is a collection of files, and each department will have its own files. So in this case, accounting has its own system that is supported by a collection of files. And these files are separate from the collection of files that support the production system that serves marketing. So there are two different systems in this particular example. This system that serves accounting and this system that serves marketing. And each system has its own set of files that support it. So this system will save and retrieve data to files that are separate from the files that will be serving this particular system. And the word flat file there really talks about a file, for instance, conceptually, that looks like this, that there's no hierarchical structure. It's just flat, as we said. So in this particular example, perhaps you're building a system for a government department that monitors universities within a particular country. And so here we have the names of the universities, and these are individuals who teach in these universities, and we also want to know what faculties and departments and office blocks they are occupying. So in a flat file, there's no hierarchy. Now, what are the problems with flat files? Well, really, the key thing really is that idea of redundancy. Remember, we talked earlier about redundancy, I believe in chapter 1, and we said redundancy sometimes is good. For instance, when you are creating backups, you are making a copy of your data, or a system like the internet that has so many nodes that are redundant, so that if a particular node dies, the system still continues running. But in this particular case, we are looking at redundancy, and we are saying about it that it's actually a bad thing. One of the challenges, let's maybe just go through one or two of these items. The storage costs can be quite high. For instance, if you go back to this system, you can see here that the accounting department maintains data that we refer here as customer data, but marketing also maintains data that we call customer data. So you may have a lot of data about customers that accounting is maintaining, and also have a lot of data about customers, the same data that marketing is also storing on their own hard drives. So the two files are separate. The two departments are responsible for managing the data in their custody. But in each case, you need storage, you need hard drives, you need a server, for instance, to manage that data. But also you need your hard drive and the server to manage this data. So you are duplicating the data, and that forces you then to duplicate costs. You have costs to maintain that database, well, that file, and the same amount of resources and money are then required also to manage this particular file. So that is what it means when it talks here about excessive storage costs of paper documents and or magnetic form. So in this example, we are thinking about hard drives and basically the IT infrastructure that you need to manage your files. But also your system may be paper-based, in which case it means that you have a huge drawer containing paper files regarding your customers, data about your customers. And also you have another huge drawer in marketing that contains essentially the same kind of data. And immediately you can see, for instance, that there are going to be challenges in terms of keeping the two copies of data in sync. Imagine, for instance, that a customer here, Mary Jane, gets married and changes their name to Mary King. Perhaps accounting is aware, but marketing is not aware. And now the data suddenly is out of sync. So later on now, when perhaps the head of marketing and the head of accounting are sitting together with the other heads in a meeting of executive management, they don't know that they are talking about the same customer. So that makes it easy now for them to ultimately make decisions that are suboptimal. Okay, so when you update, ideally you should be updating that file and that file. If you do actually do that, then again it means that there's duplication of effort. So it's costly in that sense. But also there's that danger that in a lot of cases you may not remember or may not know that you need to update this file as well. In which case the files now become out of sync. And so ultimately the idea here about data integration is that it becomes difficult. Now, supposing you are producing a report that reads data from the two different files. Measuring the data from the different files to create this one report becomes a challenge. So in general, you don't want um, to depend on this kind of model. You don't want a flat file model. Ideally, your enterprise must move to a database model. In the database model, you have a single place where all the data is stored, and that data is managed by a piece of software referred to as a DBMS, a database management system. So now all the departments, all the users have access to the same data. So when accounting makes an update for the data is updated. And when marketing runs a query against the database, that update is visible even to them. So suddenly all those challenges about inconsistencies and records and they disappear because you have just one place where the data is stored. Looking at this conceptually, you could look at it this way, that this represents a hard disk, hard drive on which all the data is stored, and this is a DBMS, and the two of them are essentially on the same machine. So the users have machines running on their desktop and they connect to this machine through some network channel. In reality, of course, your database could be spread over several machines. Remember earlier in chapter 1, we talked about distributed database and distributed processing. So conceptually, it looks this way, but in practice, you are free to arrange the architecture whichever way you feel would be beneficial to you. So not only are you saving in terms of storage, in the sense that your data is in one place. Remember, in the flat file model, your data was in several places, so you were forced to buy several disks because of that. But in this case, you can now use only one disk. But it also means that now when you are taking backups, you only need to back up this particular this one place where your data is stored. Okay, so in a nutshell, this is your database model, and it is the model that nowadays we expect really people to be following. Okay, now when talking about transactions and how we process transactions, usually we will distinguish between what is called batch processing and what is called real-time systems. And you can read the book about all of these things, but the key difference really is this issue about time. In a batch processing system, you group similar transactions together. So as the transactions occur, you accumulate them. You are not processing them. You are just accumulating them, and then later on, now you process them as a batch. So a batch essentially is a group of similar transactions, and that are accumulated over time and then processed together. So perhaps people are buying and you accumulate those transactions, and then later on now you can, for instance, capture them onto your computer system. Perhaps you are issuing receipts and you are keeping a record of what transactions have transpired, and then later on maybe in the evening when now you have closed shop, now you sit down and you start processing those transactions. And if you do it that way, well, here are the advantages, and you can read also about the disadvantages. But another important factor is that those transactions must be independent. You can't have transaction 10 depending on transaction 3, because remember, you haven't processed transaction 3. It came in, and you just put it aside and stored it. So now if transaction 10 depends on transaction 3, um, that would pose a serious challenge. So you are talking about transactions that are independent of one another during the time period over which you are accumulating the transactions. If you are accumulating transactions today, maybe on a daily basis, you process them only in the evenings, then a transaction that comes at 3 should not depend on a transaction that occurred at 11 during the same day, because the transaction that occurred at 11 has not yet been processed. But it will be okay for the transaction that comes at 3 to depend on a transaction that came at 11 yesterday, because yesterday's transactions were processed already yesterday evening. So that is something that you would need to keep in mind. So yes, in batch processing, there's a time lag between the actual event and the time that we process the data pertaining to that event. And in real-time systems, we process transactions. We don't accumulate them. We don't batch them. As soon as a transaction occurs, we process it at that moment. So there's no batching. So for instance, when we are buying goods at a supermarket, and the checkout the assistant scans our item, the transaction is being processed at that moment. They are not recording it in some book so that they may later then process the batch together. It's processed online. It processed in real time. And yes, again, go through the book, but you will see that as always, there are advantages and disadvantages that go with each of these approaches. And within the context of your organization, you will need to decide what is most appropriate. And here's a slide, a picture from the book that compares the two approaches. Again, I will let you go through it and also on your own, and also think about why in practice people do still use batch processing. Okay, so now let's talk about coding. Here is that example that we were looking at earlier when we were talking about the flat file model versus the database approach. Now, in this case, notice that okay, maybe before we do that, in this case, each row represents a record. So for instance, this row is a record pertaining to this individual. And these things then are fields within the record. And the individual letters here are characters within the fields. So for instance, in the field called department, this physics is made up of characters. The entry here is made up of characters. So when talking about flat files, these are the words that you use. The file is made up of records, and each record is made up of several fields, and you can even go further and break down the entries in the fields. And so the characters that actually make up that particular field. Okay, so in this case, notice that this record appears to be identical to this record. So we seem to have duplicated this entry pertaining to David Masiri. But imagine that in reality, actually, was correct. We do have two David Masiras, both of whom teach at this university, and they're in the same faculty, in the same department, and their offices are in the same block. But they are two different individuals. How do we tell them apart? Well, typically we would use a code of some sort, a code that would allow us to uniquely represent each individual. So in this case, we are thinking, of course, of an ID. If you are dealing with customers, you would have a customer ID that uniquely identifies a customer. So when we say customer, the customer with ID KK24, then we know that that KK24 is unique and it uniquely identifies this particular individual. Of course, if you are building a system for a university, for instance, your students will have IDs. Again, the idea there is that this code that we call ID is a code that will uniquely identify each individual student. Even if their names are the same and their surnames are the same and their dates of birth are the same and their nationalities are the same, and they are two separate individuals, and we need a way in the system for us to be able to tell them apart. And we use that, we use codes to do that. And as it says here, code can also be used to, on top of that, to concisely represent large amounts of complex information that would otherwise be unmanageable. Imagine, for instance, here, again, we are writing a system for some government department that oversees universities. And imagine in that country, we have a university here, perhaps called, I don't know, maybe Kim Mohozi IV, University of Science, Technology, and Legal Studies. So that's a very, very long name. And maybe there are 250,000 individuals working for that university. So it would mean that in this particular file, again, remember this is your flat file model that we are looking at here. In this particular file, it would mean that that loan name, Kim Mohozi IV, University of Science, Technology, and Legal Studies, would appear 250,000. And you know, the amount of storage of space that we need then to store that name would be quite substantial. In the bigger establishments, of course, your banks and your online shops and your mobile phone companies, and you know, you are talking about a much large number of customers. You are talking about millions of customers, sometimes even billions of customers. So in that case, the amount of storage really becomes substantial. And so if you were to use a code, maybe rather than have that loan name, maybe a code that says MOG4, and every time you have an individual who works at that university, you simply write MOG4, but you have a link to a file here that tells you what MOG4 is. Then you would actually save a lot of space, because it means that you are storing the complete name, the very long name, only once, and the code now is the one that would occur many times, but it's a short code. So the amount of space that you need to store that short code will be quite reasonable. So that is what it means when it says that you know, you can represent. Sometimes you may be linking, in fact, to an image that again is quite huge. So rather than have the image reoccur in this file, you store it once elsewhere, and you can look it up. So when you do this, you have a table here that gives you the codes and the university names. You know, there's a code for that university, a code for that university. So here you are only capturing the codes, and there's a table that gives you the actual names of the universities that is linked to our file here, then that table may be referred to as a lookup table. So when you encounter a code here, you can look up the full name in the lookup table. So that is those are the basic ideas behind the use of codes. But then you may say, well, okay, I want to do that. I want to use codes. How then do I assign codes to individual items within my file or within my database? The individual items may be customers, they may be parts, they may be units such as cars, they may be books, but how do I assign a unique code to that individual item? Well, there are many different ways of doing it. You could simply say, oh, sequentially, the first item that I meet will be 1. So the first university in this case that we meet is 1. So now nickel belt is 1, button is 2, nickel belt again is 1, button is 2. So in this file, then it will be 1, 2, 1, 2. And if you want to find out what 1 is, we go to the lookup table. So we would just simply be, and in fact, your system, if it's a database, even a database management system, even something like Microsoft Access can do that automatically. Just assign those sequential numbers as the items come in. But there will be it's simple, but there will be, as always, advantages and disadvantages. Take the time again to look through, and you can represent whole blocks and say, okay, this block will have a code that looks like this, and that block will have a code. Maybe different types of engines. All the engines will have a code that looks like this. Maybe that begins with ENG, and then maybe the rest of it is sequential. Or you could have a slightly more complex system. For instance, in this example, you get a number that says 0409. It's a long number like that, and actually it is made up of parts. Each part tells you something. So the 04 is a store number, the 09 is a department number, that is an item number, that's a salesperson. So now this is slightly more complex than the previous approaches than the previous approaches that we were looking at. And so when we are looking at a code, it encodes so much information. It is not just about it being able to help us uniquely identify some particular store. It goes beyond that. It tells us even all the way to the particular salesperson that we were talking about. So those are of course, again, you could use numbers. Excuse me. You could use just letters on their own, A, B, C, D, or you could use letters in combination with numbers. You are free to do that. Okay. Now, another, if you remember, going back, for instance, to your primary school, you remember, things like soccer tour, things that are codes that also are intended to help you remember what they encode. Or later on at secondary, talking about the colors of the rainbow, some people will use the code Roy Gibiv, or backwards Vib Giwa, I think it was. So that is a code that also helps you to remember what it is encoding. So when we say Roy Gibiv, we know that those letters stand for colors, and that helps us remember what colors they stand for. Or when we say soccer tour, we know what we're talking about science, and so the code is designed to be able to assist us to recall the information that it encodes. So those then are the different ways of putting together your codes. Um, Go through and try to understand them, understand their differences, and also understand their limitations. For instance, if you use a single letter, to represent something, then it means that, assuming that we are talking here about the English alphabet, perhaps you only have 26 variations. Although you could increase the number of variations if you were to say, well, I, capital A and small and uppercase A and lowercase a represent two different things. Then okay, now you can say, well, maybe 52 options now are available to you, but at that point they are finished. If you use two letters, then that gives you obviously more options. Okay, so the number of characters within your code um, may be important if you want to ensure that you are able to represent all the options that you need to represent. Okay, let's move on and talk about documentation techniques. When dealing with systems, complex as they are, we need to document them. Documentation may be important, for instance, for people coming in after us, after we have left. Perhaps we were fired, perhaps we died, perhaps we resigned, perhaps we were promoted. Somebody comes in now to look after the system, and they want to understand how the system functions. So in that case, if there's documentation of some sort, then they can refer to documentation and try to understand how the system works. But it is only useful for us, those of us that design the system, because we forget things. We make choices and we forget why we made those choices. So we need to be able to go back to some kind of record and say, but why did we do it this way? Otherwise, we might have done it that way to avoid some particular issue. Now that we've forgotten, we may in fact now make changes that take us back to the issue that we are trying to avoid, and therefore maybe result in some kind of harm or loss to the organization. So, 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 so it is important that we document systems, and also that we find efficient and effective ways of documenting those systems. Sometimes, of course, documentation is important for communication purposes. When you are designing a system, the designers need to exchange information. They need to discuss. They need, and so, for instance, if you have your computer professionals and your accounting professionals who come from different backgrounds, ideally you should have a documentation system that the two teams both understand, so that they are always in sync in terms of the kind of things that they are talking about. So there are many reasons why it is important for us to document systems. Even when you are writing a small system, a function, you need to document it, because when you come back to it, even after a short period, maybe 3 weeks later, you are going to struggle to understand why you made the design choices that you made. So there are many reasons why we need to document systems. And there are many different techniques that people have developed over the years to document systems. Your book, for instance, refers to these five, that you can use what is called an entity relationship diagram, or you can use data flow diagrams, or document flow charts, or system flow charts, or program flow charts. We will be looking at them, using them, in fact, quite a bit from, I believe, chapter 4. And so here, I will just fly through them to help you get ready for when we actually now start using them in detail. So here is an example of an ERD, an entity relationship diagram. And an entity, usually people will define it this way, that it is the thing about which we want to keep data. For instance, if we are writing a system for a small university, we want to keep data about students, so we will have an entity called student. We want to know what their names are, their first names, their last names, their dates of birth, their gender, their nationality, and all of that. So we want to know all of that about each student, and therefore we want to maintain data about students, and therefore we will have an entity called student. In many businesses, of course, we are dealing with customers. We want to keep data about customers, so we will have an entity called customer, and we will have an entity called vendor, and the people who supply us, for instance, with the raw materials that we need for us to be able to produce the finished products that we produce. So those would be entities, and entities are related in some way. For instance, and the entity customer and the entity order are related somehow. And the relationship in this case is that the customer will place an order. So a customer places an order. But you also have what are called cardinalities. And in this case, the three options, of course, are one-to-one, one-to-many, and many-to-many. Let's begin with this one, the one-to-many. So essentially here, what we are saying is that a customer places an order, but the customer can in fact place many orders. So there may be order A and order B and order maybe 10 different orders from the same customer. Not necessarily the orders coming simultaneously. Perhaps over a period of 3 months, for instance, a customer may place 200 orders. So one customer places many orders. So we're reading this association, this relationship moving from the left to the right. That a customer can place many orders. But we also have to be able to read the relationship moving from the right back to the left. So in this case, what this is saying is that each order will only come from one customer. Yes, the customer can place 10 different orders, but each one of those orders comes from only one customer. You cannot have an order that comes from Jane and from Dawn. Jane can place many orders, Dawn can place many orders, but when we look at an order, the order always comes from one customer. So reading it that way, we are saying a customer can place many orders, but now going that way, we are saying each order can only come from one customer. It may be a little confusing, but it's actually quite important. Sometimes you have a one-to-one kind of relationship where you say a man, for instance, can marry only one wife and only one woman, and a woman can only be married to one man. So that would be one to one. Of course, in some places, one man may marry many wives, but each of the wives is only married to one man. So that would be a one to many in that case. But the usual arrangement, at least nowadays in this part of the world, would be a one to one. But of course, you also have many to many relationships. I don't want to talk about many to many in terms of marriages. It will sound a little bit strange, but that would mean that I'm not talking about it that way. I'm just saying that if you were to talk about it, we would be saying that one man can marry many wives, and each one of those wives can be married to many men. So that would be a many to many kind of relationship. So in summary, then this is your ERD, and it is one of the more popular documentation techniques, especially when now you are designing databases. Okay, you can also talk about what's called a data flow diagram, which uses symbols to represent processes, data sources, data flows, and entities in the system. And here are the kind of diagrams that you would be using when using a DFD to represent the logical elements, not the physical, but the logical elements of your system. So to represent an entity, you would use a box like that, and in the box you write the entity name. To represent a data store, data goes into a store of some sort, whether it's a physical file or it's a database, you would use a diagram like that. And to represent a process, you would use a diagram like that, and an arrow would then show the direction of data flow. Then you can talk about system flow charts. As I said, there are many different documentation techniques, and one of the challenges is that now that there are so many things, so many diagrams that one needs to remember. What does this diagram mean in this context, and what does that? It can be confusing, especially initially, but with time, one begins to become accustomed to these things, especially if you choose a particular technique and perhaps try and stay with it. Because remember, the one of the key things here is that your technique must help reduce confusion. When you are designing a system, and as a designer, you are discussing it perhaps with your ultimate end users, the technique should help reduce confusion. Or when the designers are discussing it among themselves, if your technique introduces confusion, then it is counterproductive, and in the end, your system may fail, may become suboptimal because of your your documentation technique. So a technique must be an aid that ultimately, excuse me, helps you design a system that meets your requirements, and also do it within budget. So you need to think carefully within your organization about the kind of techniques that you are going to be using, and also try to ensure that the people who will be working with these things do actually have a common understanding of how these techniques work. So when talking about system flowcharts, here are the kind of symbols, the symbols that you will be using to represent things within your system. For instance, that is how you would capture a manual operation. That is how you would represent a source document. Um, and document flowing, and how you would represent accounting records, and so you need to know the meanings of these diagrams, so that when you look at a representation of a system, you are immediately able to see that, oh, okay, this operation is manual. Okay, here we're talking about source document. Okay, this is just a connector, um, and and all of that. So here is an example of a flowchart, uh, uh, and looking at this. What did we say that symbol meant? Well, if you go to the previous page, it's a terminal showing source or destination of documents and reports. So in this case, there's something that is coming from a customer. And because we are thinking about sales, essentially we are saying that, for instance, a customer has given us a purchase order. So some document is coming um, from the customer, and that document is a customer order. And again, when you look at you can see that this represents a document. So that is the shape that we are using. And then something happens, we prepare sales orders. And that shape of the box tells, I wanted to go back. That shape tells you we are talking about a manual operation. So in this case, we are talking about a manual system, not a computer-based system. So when a customer gives us an order, we do something manually. And that process then will give out some kind of documents. In this case, the document that comes out is a sales order. And remember, I think, I don't know, that was chapter 1 or earlier this chapter, that's we will be preparing an order, excuse me, in several copies, so that all the various departments that need to be informed will each receive a copy. Okay, and now here is a more complete diagram that tells you what happens even across departments. So it begins with the customer interacting with us through our sales department. There are things that happen. Notice now that there's a copy of our sales order 1, that goes to the credit department. Okay, again, try and go through this and understand it, because that will actually help you a lot later on now when we are looking at processes in chapter 4 onwards, not just chapter 4, but the other chapters as well. Okay. More symbols, again, take the time to try to understand them. Remember, for instance, we had that shape that represented a manual process. Now it's a shape that represents a computer process. So contrast and compare and try to make sense of what is going on. Okay, more pictures. All of these come from the book. So please go to the book and spend some time with them and begin to understand. This now is a program flowchart. It's the kind of thing that I don't know whether people still do this, but the kind of thing that people used to use when now they are designing the actual computer program. And so now they are more or less at the implementation phase. You designed your system, you have all the components. Now you need to design the actual code that will be running on your machine. So these are the things that that people used to use. Again, go through and become familiar with these things.